Hey guys, welcome to 0.4 Booleans and Conditions. Now before we start this, I wanted to just show you how to better organize your notes for each lesson. So first of all, note how I have changed the name of the file for 0.3. This is the last video. I've renamed it to just 0.3 note.py, and I think that's a nicer way of naming these. So from now on, we'll just call each program, each file that we create per lesson, just like this. Now the other thing is we want to kind of like explain each of these parts of the code. Now each of these is really an example that we did in our note from that day. So let's first of all uncomment all of the lines, right? Because we'd commented out some of these so we could run the different examples. So uncomment everything, and let's now take this string, this comment that we'd created, and we'll select it, Control X, and let's paste it in front of the lesson or the example, just to show what this example, the point of that example, converting to a string, right? And then our second example, again, let's create a little comment in front of this, and this was about converting to an integer, right? And this is the one where we just converted my_num to an integer. And finally, let's do it again here. This was an example of nested loops. Now we also talked about converting to a float, so you could even add a third example or a fourth example to this if you like, and make your own little example to kind of finish off this note, right? So for example, you could that came after converting to an integer, so you could say converting to a float and maybe just print float version of 10, right? And that would of course print a float version of the string 10. So even though we did that part in the terminal, you can still add an example in the note. And feel free to add more examples of anything else that we talked about in the lesson to your note so that you have a good record of what you learned for this section. So then let's check out section 0.4, Booleans and Conditions. So in this video, what we're going to do is learn to manipulate Boolean variables and use Boolean comparison operators. We're going to use if statements to execute conditional code, and we're going to work through a bunch of examples and more problem solving with input-output tests to determine whether we're doing it correctly. So the Boolean data type, well, every value in Python belongs to at least one data type. And so far we have learned about integers, right? Numbers like 1, 2, 3, 4, floats, all those numbers and the ones in between, strings, which just means text. And now we're going to learn about Booleans. So Boolean's data type, it only has two values. So a Boolean data value can be true or false. Now, we have to be careful when we write these. We need to use an uppercase T or F in front of true or false, or else the compiler won't recognize that we've typed a Boolean value. So here, right, if we just used true or false with lowercase, this would give us an error. Let's just try assigning some Boolean values to bacon and eggs in the terminal. So we can set bacon equal to true, and we can set eggs equal to false. And note, guys, that these are not strings, right? There's no quotes on true or false like help and copyright. So if we type these into the editor up here, then you'll actually see the words change color because VS Code is recognizing the Boolean values true and false. Now, assigning true to bacon and false to eggs basically means that the variable bacon contains the Boolean value true, and the variable eggs contains false. Now this is handy because we could later change the values of bacon and eggs depending on what's happening in our program. So this leads us to the idea of Boolean comparison operators. So the comparison operators compare two values and evaluate to a true or a false Boolean value. And here's the list. So you guys have seen these before, probably in math class. This is the less than symbol, the greater than symbol, or here we have less than or equal to, or greater than or equal to. Now the order of these matters. Make sure you put the less or the greater than symbol first. Now this is the equal to comparison operator. Notice how we have two equal signs here. And the not equals operator starts with a exclamation mark. So that kind of means not equal to. And when you use these in conjunction with numbers or variables on either side, the computer will look at that expression and try to determine whether or not that expression is true or false. So if you see here, 10 greater than 5, well, we know that that is true, right? 10 is greater than 5. So this would evaluate to true. Let's just type that here. 10 greater than 5. And you can see it says true. And this is essentially what a condition is, right? A condition combines two values with a comparison operator. And we often use these in if statements, which are coming up later. So here's an example. Let's say we had the variable guess and the variable number, right? So two different variables. We don't know what's inside them. But if we wrote guess is less than number, right? If we type that in, then the computer would say, hey, is the value stored in guess actually less than the value stored in number? And if so, then the condition would evaluate to true. And if not, it would evaluate to false. So let's say that we have the integer 10 in guess, right? And the number stores the integer 16. So this one contains 16. Well, because 10 is less than 16, we would know that this would evaluate to true, right? So we type guess less than number. Really, what the computer would do is just actually replace each of these with 10 and 16, respectively, and then evaluate to true. So let's experiment. Here's a big list of things that we're going to type into the terminal and see what they evaluate to. So we'll start with 0 is less than 6. Well, we know that's true, right? 0 is less than 6. Now, if we type 6 is less than 0, well, we know that 6 is actually greater than 0. So, of course, that's false. How about 10 is less than 10? Again, right? Those are equal. So we know that 10 equals 10. So if we type 10 is equal to 10, then it comes out true. What if we type 10 is equal to 11? We know that that's false because those are not equal. Or 11 is equal to 10. It doesn't matter the order here because still 11 is not equal to 10. However, we could use the not equal to operator. 11 not equal to 10. And it says, hell yeah. How about with strings? Hello equal to hello. Well, we know that those are the same string. So again, it says true. But if we were to type hello is equal to goodbye, then of course it's false because those are not the same strings. Well, what if we typed hello with a capital is equal to hello without a capital? And those again are false because remember, a string is case sensitive, right? So anything in this program is case sensitive, and the capital H is not the same as lowercase h. And of course, when we work with two different types of data, like 32, an integer, if we say, is this integer equal to the string apple? It's going to say false because those are even harder to compare. What about 32? The integer is equal to the string 32. Again, that's false, right? But if we said the 32 is equal to int and then put in our string 32, now we're true because we converted the string 32 to an integer. Now here's a huge point I want you to note because as I was learning this course, made this mistake so many times. Maybe you won't because I've pointed it out here. But the double equal sign, okay, this is only used for conditions, all right? Whereas the single equal sign is used for assignment statements. So what I mean to say is if you type a equals 5, we just stored the value 5 in a like we've done before. Okay, but if you type a equals 4, what it just did is compare the value of a to 4, right? So these are completely separate. You have to just remember that whenever you're trying to evaluate an expression using a condition statement to use a double operator. They're always double operators, except for except for these greater than or less than, right, ones right here, these first two. So that brings us to if statements. So an if statement initiates a block of code that runs if the condition it contains evaluates to true. So here's an example. So in this little example, we have a for block that initiates a repetition structure. And then within that, we have this condition that if x is equal to 5, we're going to print x. So I want you to think for a moment, pause the program or the video, and what do you think this program will output? So let's find out. Let's go over here and we'll type this sucker out in our note. So let's say example 1. If statements. Okay, and we'll type for x in range 10. And this, of course, starts our for block. And so if x equals 5, print x. Okay, so let's run the program. And hopefully what we'll see here is the number 5. So there it is, right? We got, basically what happened is x went from 0 to 9 and then got printed when x was 5. Now the best way to see this is actually to paste this in our visualizer. Now, in case you forget, the visualizer is pinned in Edsby on the front of our page, but you can also access it by just opening a Google or opening a tab and typing pythontutor.com. Okay. Now pythontutor.com, well, it'll bring you here and you can click visualize your code and get live help. And here's where you type your code in. So you can paste, in this case, paste your code straight out of Visual Code and then click visualize execution. Then it'll bring you to this page where you can step through your program to see what's going on. So we can click forward, and this will bring us forward a step. So after the initial declaration of this for block, the program execution goes here. And you can see now that we have x as a variable in our namespace, so which is set to 0 when this for statement is executed. Okay, so if we step forward, now what's happening is on line 2, it's checking. It's saying, is x equal to 5? But we know it's not. And so the program is not going to go to line 3. It's going to go back to line 1 and increment x. And so now x is going to be 1 after it executes line 1 again. So this is going to keep happening, of course. X is going to keep going up, and it's going to keep checking x until we get to this point where now x has been incremented to 5. And here we can now see that x is equal to 5, and line 3 executes, and the output 5 shows up in our terminal. And of course, for the rest of this program, we're not going to get past line 2. Now, as soon as the for block is complete, you can see that 9 is the very last number that it takes. Then the execution is done and the program is terminated. So what we're going to do now is just modify this program a little bit. So we'll change the program so that it'll output every number but 5. So think about what you would have to do to change your program so that we'll actually see every number in range 10 but not 5. And this is a pretty easy one. So before I give you the answer, pause the video and do it yourself. Okay, so here's the answer. So if we want every number to be printed, but not 5, then we need to just check if x is not equal to 5. So let's run that, and we should see all of those numbers show up. There we go, 0, 1, 2, 3, 4, 6, 7, 8, 9. So the next one says that we want to change it so that it'll output only numbers greater than 5. Again, pause the video, make the change. So hopefully what you did here is just change this conditional operator to a greater than symbol. And when you run that, then of course we're only going to print any numbers that are greater than 5, 6, 7, 8, 9. So the last one tells us to change the program so that it will output only the even x's in the loop. Now this one's a little bit trickier. What we have to do is use an operator that we haven't used yet, but it's a great opportunity to learn it. So now if you want to check if a number is even, then well, really what you need to do is kind of divide it by 2 and check if there's a remainder. Right? So for example, if you if you said let's do 11 divided by 2, well, we know that we would get 5 and we'd have a remainder. Technically we'd have a remainder of 1, although 11 divided by 2 evaluates to 5.5. But think about doing long division, right? Like if you guys did long division on that, or even short, right? You have 1 left over. Well, there's a way to do this to actually get that remainder in Python. We can type 11% 2, and what that means is modulus. So there you can see we have the remainder. Okay, so that will give you the remainder of any division. So let's say we did 7 modulus 3. Well, we know that would be 2 remainder 1. Or if we did 8 modulus 3. So now we would have 2 3's, but there would be a remainder of 2. Understand? So coming back to even and odd, we can check this modulus, this remainder. And if we have an even number and we type modulus 2, we're always going to get a remainder of 0. But if it's an odd number, right, then we're going to get a remainder of 1. So, so up here in our program, if we only want the even x's in this loop to be printed, then we need to check and see if x, okay, modulus 2, okay, equals 0. So what this means here is, hey, is the remainder of dividing the current x by 2 equal to 0? Let's run this, and we should see only the even numbers printed. There we go. So the next thing is the break statement. Now, the break statement can be used to end a loop. So sometimes we actually want the loop to stop before it would normally finish, right? So now when we use the break statement, as soon as the program encounters it, the computer will skip all the remaining loop code, right? Everything else in the block that comes after it, and make no further repetitions. So, and then execution resumes at the next block. So if we just added, say, the break statement to this loop, think about what would happen if x was modulus 2 was equal to 0. So, well, let's run the program. And of course, we just get a 0. Now, why is that? Well, the reason is because when x is 0, which is the very first thing x is, dividing 0 by 2 gives us a remainder of 0. So, so basically, it printed the x and it broke the loop. Okay? So I have a little picture here. Now, certain loops will actually just run based on whether or not a condition is true or false. So this is a picture of a while loop, which is something we're going to learn later in this unit. But you can see here how, right, in this loop, and that keeps going, it'll keep going around and around this circle if the condition is true, or if break encounters break, in which case it doesn't check the condition, it just goes straight to the code that follows. This is by the way, this is a flow chart. And it's a picture of executing code. It's a way of representing the structure of different blocks and the code. So let's look at this program here. What does the following code do? So pause the video here, look carefully at this code, and try to figure out what it will output. So hopefully what you predicted here is that this program is going to loop through 10 times, and it's going to start with x equals 0. It's going to come through, it's going to check if x is equal to y, which was set at 6. And if it is, it's going to stop the loop. But otherwise, it's going to print the value of x. And so it's going to output 0, 1, 2, 3, 4, 5, because as soon as x hits 6, it's going to be equal to y, and then the loop is going to break. Let's type that out here, and we'll just call this example of break statement. And we'll just comment out this part because we don't need that executing when we test this. Y equals 6 for x in range 10. And if x equals y, break. And oops, not break point. We just want break. And if not, then of course we're going to print x. Let's run that. And your output should look like mine there, 0 through 5. Let's look at this next one. So we have for letter in Python. If letter equals h, break. And so if it doesn't break, then we're going to print this, right? Print this this stuff here. So pause the video here again and figure out for yourself, what do you think this is going to output? Okay, so we'll type this one in too. And we should comment out this first one. There we go. So we'll call this another example of break. Okay, so for letter in Python, if letter equals h, break. Otherwise, print current letter, comma, letter. Okay, and when we run that, we should see current letter P, and then current letter Y, current letter T. But of course, the reason we don't see H is because when the loop hits the letter H, when letter takes the string H, okay, then basically the letter is equal to H, and we break the loop and do not print, right? We do not execute any more statements part of that loop. And so something cool here to note is that when you use a string to iterate through, then the value of letter is each character in this string, right? So it goes one character at a time, and letter takes each of those characters in the loop. So we don't have to use just a range object with numbers. We can use a string, and of course there's many other types, data types that you can put in here. But the for loop will let you go through each thing it contains one at a time. So the next thing is the else statement. Now, in many situations, we want to run some other code if the condition in our if statement is false. And we can use an else statement for this. So have a look here. So if some sort of condition, one or more condition is true, then we're going to execute the block, and that's what we just learned. But you can then next add an else statement. So else, or what this means is otherwise, don't include that. That's my explanation. Colon, we start this other block, and this is block B. So we'll be writing, the program will be executing whatever code we put in here. So let's do an example of this. So the example 2 says, write a program that reads a number and outputs positive or negative depending on its sign. So let's go over here, and we'll type example 2. And again, if you're able to, if you have the time, pause the program right now and try to do this yourself. So let's just add using else statements, just a little bit more descriptive. And here's the solution. So the first thing we want to do is read a number from the user. And so we need to just use a variable. We'll say my num equals inputs. Now, remember that this is going to give us a string. So let's actually convert this to a float right away so that my num contains a number that we can use arithmetic on in order to check whether it's positive or negative. Okay, so now we've got a number in this variable, but we have to check if it's positive or negative. Well, of course, one way of doing this is just checking if it's greater than 0 or below 0. Right? So a positive number, right, is going to be 0 or above. Negative number is going to be less than 0. So what we can do is just say if my num is less than 0, colon, right, then what we'll do is print negative, because we know that my num was less than 0. Else, and we start a new block. Now we don't need another condition here, and the reason is because this is literally the only other option, right? If my num is not less than 0, then it's going to be greater than 0. And so we can print positive. So let's execute this. Okay, so I forgot to disable this one, but that's okay. We can still type our number in here. So if I type in 50, then we see positive. I'm just going to comment this out, and we'll run it one more time and make sure that this will in fact return negative, and you can see there that it did. So this is conditional code, guys, right? Because what's happening is if my num is negative, less than 0, it's going to run this block, but otherwise it's running this block. And this is the essence of writing conditional code and using if and else statements. But often it's a case where we want to check a whole bunch of different conditions and only run one of the blocks, depending on which condition is true. And for that, we can add elif statements. And these things go right in between if and else. Here's the structure. Now, elif stands for else if, to imply that this is going to run else. This is going to run, it's linked to the if block that comes before it. So if condition A is true, execute A. But if it's not, then we'll check condition B, right? And so we can keep adding multiple elif conditions with other conditions it can check until one of them is true. And if none of them are true, then finally it gets to the else block and it executes condition or code block C. Now we don't even have to have an else block at the end, in which case if the execution got all the way through with no conditions being satisfied, then none of them would be executed. So let's do example 3. Write a program that reads a number and states whether it's a multiple of 2, 3, or neither. And again, here, pause the video and see if you can just use this. See if you can set it up and figure out the answer yourself. So hopefully you had a chance to try that. But if you didn't get it, well, have a look here and we'll do the solution together. So example 3, using elif statements. Okay, so the first thing we need to do is read a number. So we can type my num2 equals int input, and we could use int or float there. Either way, we'll get a number that we can work with numerically. And then we have to decide if we are a multiple of 2, if this number is a multiple of 2 or 3 or neither. So really, we need 3 conditions here. And we can use an if, an elif, and an else. Now, the answer here has to do, again, with modulus. Right? We know that a multiple of 2 should be divisible by 2. In other words, the remainder of dividing the number by 2 should be 0, right? It's the case with all of these numbers that are multiples of 2. And for a number that's multiple or divisible by 3, or a multiple of 3, we should again be able to divide that number by 3 and get no remainder. So we can use these as our conditional operators. So we can say if my num2 modulus 2 equals 0, that means we have an even number, or sorry, a multiple of 2. So we can write multiple of 2. Now, if that's not true, we can say elif my num2 modulus 3 equals 0. So this would say, hey, can we divide it by 3 and get no remainder? And if so, we have a multiple of 3, right? Now, of course, if neither of those conditions are true, then we know that that we will not have printed anything yet, and so we have something that can't be divided by 2 or 3, and we can print neither. Now think for a moment here about any potential problems that this program might have. Well, let's just run this program and see what happens. Let's test it out. So we'll press F5. Now we'll start by typing something that we know is neither. a multiple of 2 or 3, and it says neither, which is great. So let's run it again. How about 8? You know, that's a multiple of 2, so that's working great. Press F5 again. How about 9? Multiple of 3. That's great. But let's try one more. We know that 12 is also a multiple of 3, so this should... wait a minute, it says multiple of 2. Well, of course it does, because it is a multiple of 2. But notice how it's also a multiple of 3. Now, we'll eventually be able to code this program so that it can print both of those. It takes multiple conditions in an if statement to do that. But for now, just recognize that this is actually a good little teachable moment. Quite often when you're making a program, it won't quite behave exactly as you expect it to. And it's up to us as the programmer to figure out how to improve that code and refine it so that it functions optimally. And the reason, of course, that this outputted multiple of 2 was because only one of these 3 blocks can be run. And the very first condition, when we check to see if the mynum is divisible by 2, has a remainder, this evaluated to true, and so this printed multiple of 2 and then skipped the remaining conditions. So I just want to finish by just mentioning this again, although we talked about this in an example. We can also, of course, loop through a string's characters, right? And we did that in a previous example, but here it is again for letter in hello there, print letter. So if you were to type this out in the next example, you'd see, right, that every letter would be printed. So let's just do one last example so that we have something in here. Example 4, we'll call this looping through a string. So if we have 4 letter in hello there, colon, and we type print letter in our for block. So when we run this, basically, we should see that each letter will, that letter takes each letter in the string, and each time this runs, it will print a single letter from the string. Let's press F5, and you can see there they all are, hello there, right? So each time the print statement runs, it prints whatever you put in here and then puts a return, a carriage return, so that we get a new line after it. So that concludes our lesson for this day, 0.4. You can go to Replit now, and you'll find for this section that there are a whole pile of assignments A through G that you can work through to practice these skills. And of course, make sure to give me a shout if you need some help or if you're running into a lot of trouble. All right, good luck.